Hi, this is Sridhar, and welcome to another episode of Amazing Astronomy. So, we're going to cover a couple of items today. One is the Ring Nebula, which is in the constellation of Lyra, and the two, we're going to talk about white dwarfs. So, let's jump right into it. Ring Nebula. Now, the word nebula means cloud. So, as you can see here, this is an image of this object in the constellation of Lyra. And the French astronomer Messier cataloged this as number 57. This object is 2,000 light years away from us, pretty far away. And it's actually not a star, it's an exploded star. So at one time, this particular object was a sun-sized star, so not that much bigger than our own sun. And what happened is over time, it started to die, and eventually it blew up, and then it shrunk down to the size of what's called a white dwarf. So before I go into a little more detail, I want to show you an even better image. This is from the James Webb Space Telescope. And as you can see, it's an astounding photo, an image. And I want to explain some of these colors because this is, I think, extremely cool. Look at this outer ring. This is all nitrogen. It's been heated up. And on the spectrum, nitrogen that's hot is red. And then oxygen is the next ring in here. You can see that it's green. And then the center is really hot helium, which is blue. And so these are the colors of the spectrum. And then you'll notice it's almost like an eyeball here, right? These are like eyelashes or spikes. Sometimes they're called knots. And these are also artifacts of that star that blew up. Now, let's talk about the star in the middle. And that is the very extra cool thing about this and why I like the Ring Nebula. See, right in the middle, there's this little tiny dot. That's actually called a white dwarf. Now, what is a white dwarf? As I said before, it is a star that has shrunk down to a very small size. So I'm going to use our own sun as an example. So in about 5 billion years, our sun is going to die. It's going to run out of nuclear fuel that is powering it and making it so bright. So in about 5 billion years, it's going to turn into what's called a red giant. As you can see here, this is not to scale, by the way, absolutely not to scale. The actual sun will go well past the orbit of probably even Mars. So it's going to expand. It's going to be very red. Red is actually cooler than the current temperature of the sun. And then at some point, it's going to run even more out of fuel. And then gravity takes over and compresses this down to the size of Earth. So our sun will be the size of our Earth. What's different is that the gravity is tremendous. It's 100,000 times the gravity here on Earth. So if you weigh 100 pounds, let's say, or maybe you're a teenager or something, you would weigh 1 million pounds, right? Now, what's fascinating is it's called degenerate electrons. All the electrons are shoved together in a tight packed formation, and they crystallize into carbon and oxygen. So this is actually a diamond. Think of this as a giant shiny diamond. It doesn't emanate a ton of light, so these are hard to detect, and they're also very small. As I mentioned, this is the size of Earth. So I hope you learned a couple of cool things today. One is a white dwarf, and two is about planetary nebulas or stars that have exploded and left behind a cloud, a nebula. So please keep looking up, uh, learn and observe our wonderful universe. And if you could please either like or subscribe or share what you enjoyed about today's talk. Thanks so much and see you soon.